So hello, everyone. Today we have Dr. Arcan, who's going to present on sugar is the latest finding on artificial sweeteners. But
Okay. Hello, everyone. My name is Chrisa Arcan, and I'm an assistant professor in the Family Population and Preventive Medicine in the Medical School at Stony Brook. I'm very pleased and happy to have the opportunity to discuss with you a few things about sugars and artificial sweeteners. So let's see. Okay. We begin with our objectives. We're going to discuss the definition of sugars and artificial sweeteners, then how the glucose is metabolized, so we understand when we talk about artificial sweeteners after that, the difference between glucose and fructose, and in general, how much sugar is consumed in the US. And then we're going to delve into more details about the artificial sweeteners and their health effects and some alternatives if we want to use more. So we have different types of sugars. They're the naturally occurring, the ones that you probably are familiar. It's the glucose, fructose, lactose. These are the simple sugars that they're being metabolized in the body. So sucralose, which is the table sugar that we use, and you will see later, is made out of glucose and fructose. And then whole fruits naturally contain both. So then we have added sugars, which are still naturally occurring, with the brown sugar, corn syrup, dextrose, honey, and molasses, etc. But then we move on to the artificial or non-nutritive sweeteners. So this is the distinction between the naturally occurring and the artificial ones. But before we try to understand the artificial sweeteners, it's important to understand how sugar or glucose is metabolized in our blood, in our body. So we eat the food that we eat, and we usually eat mixture of foods. And so we have French fries or some kind of a carbohydrate, and we have our protein, which is meat, fish, etc. And we have lots of vegetables, hopefully, and fruits. So we have a combination of protein, carbohydrates, and then of course we have the fat, either natural occurring or we add when we cook. So when the food comes into our bodies, the intestines absorb, then it breaks down to their simple nutrients where they can be absorbed and metabolized by our body. So let's say carbohydrates convert into glucose, and they're being absorbed by our intestines, and then they go into our bloodstream. Then it's when the glucose or the blood sugar goes up in our body, in our bloodstream after we eat. So, so then the pancreas senses the extra glucose in our blood, and oops, sorry, I'm going back. Okay, and then it responds by secreting insulin, and the role of insulin is to facilitate the glucose, the entrance or absorption of glucose into our cells, cells of anybody, our muscles, our liver, our brain, everything. So it's like a chaperone that facilitates the absorption of glucose into our cells. So then after that happens, of course, this insulin causes the liver and the muscles to absorb. After that happens, then we reach a point where the glucose in our blood is normalized, and then we start over. So this is when everybody's healthy, and then that's the normal loop of metabolism. This is telling us exactly the same thing with a couple of more information. So let's say here on the left, we have the stimulus, which is the food, and the glucose goes up. It stimulates the pancreas to release insulin, as we said before. Now, two things happen. One, we discussed this before, it stimulates glucose uptake by the cells, but also in the liver, when glucose is metabolized, it's also stored and in the form of glycogen. You don't need to remember that, but what you need to remember is like glucose goes to the liver, and then we have a storage form which actually keep us alive when we fast, when we exercise a lot. There's a short-term glucose storage there for us to be able to survive. So then all these things happen, and then the blood glucose goes back to normal, which is a homeostasis here, like we said before. About 85 to 90 milligrams per 100 ml is what we got usually when we test our blood. Now, like I said before, for whatever reason, the blood glucose level goes down because we are fasting for a long time, or we don't have food to eat, or we exercise a lot. For whatever reason, the blood glucose level goes down. Then again, pancreas is being stimulated to produce another hormone. Instead of insulin this time, is glucagon. The name is not that important, but there is a response mechanism that stimulates the release of this storage that we said before, the conversion of the storage form to glucose again. So then again, it releases glucose, and then all these things happen, and then we normalize the blood. So this is what happens with glucose, which is a natural sugar, and our body and our brains are used to metabolizing that. And that will be very useful when we talk about the artificial sweeteners. So we have the glucose and fructose, just to separate the two, because there's a lot about fructose, and although lately a lot of foods that they had fructose or high fructose corn syrup before, now they're using more glucose because, you know, studies show that it's not as healthy, I should say, or it's metabolized a little differently. So table sugar like sucralose, it contains 50% glucose and 50% fructose. So there's no biological need for fructose, but there is for glucose, as we talked about. Now, virtually every cell in the body can use glucose for energy, but only the liver cells break down the fructose. And that's a problem. And that's why there's a lot of talk, if you heard about fructose versus glucose, which one is healthier? Are they different? They're not. This is one of the big differences, the way fructose is metabolized. And it is okay because we eat fruit, and we need fructose from fruit, but fruit is a whole food. In other words, it has a fiber and other things. And the amount of fructose that we get from our fruits is not a lot, to the point that it actually causes issues in the liver. But the amount of fructose that we get from other sources, in other words, it's being added as high fructose corn syrup in cookies, in dressings and everything, that's the problem, because it's way excessive, and that our body does not have the way to metabolize that the way it does glucose. So fructose is poorly absorbed by the cells in our gut, and it's almost entirely cleared by the liver, and that's a problem. So glucose, and this is more or less repeating what we see in the schematic, but glucose intake stimulates insulin release from the pancreas to facilitate the uptake. But fructose does not, and also causes insulin resistance, leading to diabetes. So, and that, like I said, if you have only fruits and that's where you get your fructose, that's fine, but that's not how, you know, our today's world work. And we have a lot of sources that we get the fructose, especially in high fructose corn syrup. So in the liver, fructose is metabolized to triglycerides, which is a form of fat. It's a storage form of fat. And in higher intake of sugar and high fructose corn syrup leads to higher weight and related health issues. That's where we are with, we haven't moved to artificial sweeteners yet, but I'm just trying to give you an overview of the sugars that they are in our food supply. So I want to give you a little bit of a historical perspective how with the obesity trends in our country. and the daily sugar calories per capita. So if you go back about 50 years, and when the corn was subsidized and we had a lot of corn, so high fructose corn syrup became very cheap, and it was a good substitute for sugar. So when you see here, this is refined sugar, the blue. So we start the daily sugar calories in the 70s was up here. Then a lot of daily calories from sugar, but then it started going down, 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 reducing. Then it plateaued up until 2000, and then we started talking about maybe sugar is not that bad. So we started kind of plateaued. But then what happened was the opposite occurred. Nothing here as far as the purple lines, high fructose corn syrup. And then it had the opposite trend from the sugar. As the sugar went down in our food supply, we started having more and more high fructose corn syrup. And if you see here, there's this little meeting point, and then the direction changed again. We started having less high fructose and kind of more sugar, I should say, compare the two. But look at this red line. The red line indicates obesity, US obesity. So at this point is 40%. And we're not talking about overweight, obesity. So it was down here before about not even 20%. And then it follows the same trend as the intake, a little lagging behind as the intake of high fructose corn syrup. So this is really telling about the effects of sugar content and sugar intake in general, and fructose. I'm kind of lumping everything together here, and the obesity rate. Of course, there are other issues too, lack of physical activity. But the point is, all these all these sweeteners, are ubiquitous. They're everywhere. And the more processed foods we eat, the more they're hidden, they're in there. So now we are moving on to artificial sweeteners. So as the obesity rate was going up, and the high fructose corn syrup and sugary beverages were consumed in high amounts, then diabetes actually increased, or prediabetes. So the healthcare professionals said, okay, what is the alternative? Well, the alternative was and is and still is being recommended, instead of having sugary drinks, which basically drinks, beverages, sodas and colas and all these sugary drinks are the main source of sugars, really, and artificial sweeteners. So they moved to artificial sweeteners, which basically have no calories, and they still have the sweet taste. So let's talk about the artificial sweeteners at this point. They're also called substitutes because they're not the natural ones that we talked before. They're substances that they're used instead of sucrose, the table sugar. So they're many times sweeter than table sugar. So we need smaller amounts in order to create this sweetness and the effect that we're used to. And they're regulated by USDA. So these are some examples that you probably have heard, many of them. It's and they come in different brand names, Sweet and Low. Aspartame comes in Equal and Sugar Twins. We see it everywhere we go. Then we have the sucralose that's very popular through the trade name of Splenda, and steviol glycosides, and it comes in Truvia, that's the brand, and Purvia, and then we have this monk fruit. Now the last two I would like you to keep in mind, because I am going to talk at the end about some more, I shouldn't say healthy alternatives or not unhealthy alternatives. So these are the brand names, and then some of the foods and drinks that have, and I don't know if I can see that, saccharin is 0, but then we have aspartame in Cokes, Coke Zero. A big one is Diet Dr. Pepper. Anything diet or zero, it has artificial sweeteners in them. So another thing, so drinks are not the only source of artificial sweeteners. It's also the foods that we think or we consider healthier in general. So if you look at this, there's sucralose here, and there's also sugar. So they are both in those craisins. It says 50% less sugar, and the less sugar is the sucralose, but it has artificial sweeteners. And here we say like 35% of the adult population, 32% consume artificial sweeteners, and that's from every source. About 24%, I think, from drinks. So these are other, I try to pick foods that we consider healthier and they are recommended. So here we are having Quaker, which is, oatmeal. Of course, it's got the flavors and the brown sugar, but also sucralose here and a bunch of other stuff. And then we have the no sugar added peaches. I don't have it here, but it has similar artificial sweeteners. So here's a general concerns, and then we'll get into more details about some specific ones. Consumers of artificial sweeteners may replace the lost calories through other sources. In other words, when people feel like, okay, now I'm consuming no sugary drinks or artificially sweetened drinks, I can have a little more cake. So it's just psychological. A lot of issues are related to our brain and the nerves or how we perceive the food. Others are more direct issues with our other organs and disorders. So there's possibility that the artificial sweeteners change the way we taste food. So because they have intensive flavor, it triggers cravings for more sugary foods in general. So it is also an issue because you have to realize with the receptors with our brains, and then you will see a little later that there is a connection. Tasting a sweet taste, but not having the calories or the energy coupled with that, it's leaving us unsatisfied. So I've heard many people say, well, whenever I put this or that, the artificial sweetener in my tea, I feel hungry later. Well, that's what happens because your brain does not sense the energy. So you feel unsatisfied. So here's a nice schematic of all the mechanisms, but just for you to look at. So here it basically says long-term ingestion of sucralose, and that happens with the other sweeteners. They just happen to test sucralose here. Activates an enzyme in the neural system, which causes certain cells to produce a neuropeptide that promotes hunger. That's what I was saying before. This is more of understanding the mechanism of how it works. They tested that in fruit flies. Now you're going to say, I mean, these are fruit flies, and usually animal studies might not have similar effect on humans. It just happens that fruit flies, and first of all, they can genetically they reproduce faster, but also their taste buds and the process of tasting and sensing taste is very similar to humans. So it is good to understand mechanisms there because they can manipulate things. So what happens is there's an imbalance between sweet and energy that we were saying before. And that has to do with how the sweet taste without energy is registered in the brain. So it feels as if we had fasted. So the responses, the outcomes in our body, it's almost the same, and the mechanism that happens almost the same as we were fasting. So we have increased food intake because we are hungry. And then we increase more calories that we consume. And we are more sensitive to the sweet taste. So we need it more. And we keep eating it and eating it. So it's kind of like addictive also. Again, there's glucose intolerance because of the same reasons. And for some reason, there's hyperactivity because hormonal issues are being disrupted. And because of all that, there is insomnia. Now, it depends on how much we drink or eat of this artificial sweeteners. So the more processed foods we have, the more we get them in our body. Probably if we have one little drink a day, might not affect people as much. So this is very similar to what we said in words, so you can understand better. Sweetness regulates metabolism through the brain signal. So there's a brain gut metabolism, signaling there. Sweet taste signals the arrival of nutrients in the gut and facilitate absorption and utilization of energy. So they're all connected. It's the anticipation of energy, of calories, because of the taste and the sweetness is what we register. But with these artificial sweeteners, we break that connection. So when we eat, our body produces all these enzymes that readies the body to metabolize what we sense. So that's what happens. But artificial sweeteners can impair this regulation, as we said before, because consumption of sweet taste is not followed by calories. So it disrupts that. Greater issue was when you have artificial sweeteners with other sugars, because we're disrupting that metabolism. Then when we have sugar at the same time, for example, some of the ingredients in the oatmeal had sugar and the sweetener. So that sugar is not metabolized very well as if it was only sugar. So we're disrupting the metabolic process there by having artificial sweeteners. Artificial sweeteners appear to lead a decrease in fullness and alter the processing of sugar in the body, more or less what we said before. And then we increase the caloric intake because partly we feel hungry and partly psychologically we feel like we can have a little more of better stuff. So studies have found that daily diet soda puts a person at 3 times the risk of dementia. Now we're going to talk a little bit about the neuro-metabolism, but I just added here, and strokes compared to someone who drinks less than 1 week. So it's not only the metabolism and glucose metabolism and possible weight gain for some, although that's been still debated. There are other issues with artificial sweeteners that you will see. We'll talk about it in a little while. So the same thing, they're not digested by the human body, so they have no calories, but still pass through the GI tract and impact various mechanisms, and you'll see within the microbiome. So they believe that they are inert, not active, but actually they are, and in a different way. So, but they interact with our gut microbiome. Still, there are studies going on, but you will see a small study later on that it does affect that. So, how the sugar substitute confuse your body? They've done studies about cancer, and because a lot of people are worried about sweeteners and cancer, especially the aspartame. According to American Cancer Society, they've done a lot of studies in mice and other prospective studies in people, but they did not find a link between aspartame, specifically consumption, and increased risk of cancer. Now, in order to be able for a society to produce a statement, you have to have a lot of different studies, a lot of different populations, large studies for a long time, and very, very consistent results. We all know that these studies always lack some kind of, there's some kind of an issue. Either they're small or the way they measure things, they're not the same. So it takes time for a conclusive result or findings in order for the society or the government to really say something for in certainty. So NCI, the National Cancer Institute, says that the studies have not provided clear evidence of an association. It is very hard because cancer is so multifactorial and it takes so long to manifest itself. So it's very hard to pinpoint the artificial sweeteners as the cause. So causality is hard to produce. So like I said before, most of the studies they were done using smaller amounts of diet sodas than the quantities also that we use in our daily lives. So, but there's conclusive evidence that artificial sweeteners affect our cardiometabolic health. So we have a larger cohort studies, population studies that they looked 10, people, they followed them for 10 or more years. And they showed that diet soft drinks, typically one or more drinks a day, was associated with significant increase in risk of type 2 diabetes, cardiovascular disease, hypertension, and stroke. And remember, a lot of physicians and other healthcare providers, they recommend, or they say, okay, well, you can switch to Diet Coke or anything if you have issues with diabetes. Also, prospective studies of individuals 65 and over showed 3 times increase in waist circumference compared to non-consumers. And waist circumference is an indication of a risk factor for cardiovascular outcomes. That has already been shown. So moving on to aspartame, and it doesn't mean that the others doesn't apply to the others, but there's something specific to aspartame. It breaks down to phenylalanine and aspartic acid and methanol. So a liter of diet soda will lead to 55 milligrams of methanol versus a liter of fruit juice, which is basically fructose. So basically doesn't break down as much as the other one. So phenylalanine and aspartic acid, they are amino acids that we get them from different foods. And they're naturally present. But the important thing is some people cannot break down, those who have phenylketonuria, they cannot break down phenylalanine. And you probably know that from birth. So, but some people might not be so aware. So having a lot of aspartame and sugar sweetened beverages, actual aspartame in particular, it is an issue. So the limit that FDA sets is 50 milligrams per kilogram of body weight. So basically, someone who is 165 pounds, that limit is 3,750 milligrams a day, which is very, very high. It's set at a point where sometimes you don't even reach it a day. So that's a little bit of a problem because 12 ounces a can of diet soda contains about 192 milligrams and a sweetener 35. So yeah, we get quite a bit, but I am not sure how much we can reach that point. So here I want to show you some other foods that we use a lot of sugar-free syrups, right? They're not maple syrup 100%, but they are processed artificial. But if you notice, there's the aspartame is here. And then there is also the sorbitol. So this one has 2. You'll be surprised to find out that peanut butter, which is the ones that they are not natural altogether, they have those sweeteners, and our whole wheat bread and some other power bars and other things that we think is healthy, and a lot of fruit juices that they're not totally 100%. So I'm just putting something there. Is this a food item? Because there's nothing foody in there except the water. So again, moving on to aspartame and neuroinflammation. Aspartame in particular is a neurotoxin. And I don't know why it's been allowed, but it's a neurotoxin. So long-term consumption of aspartame, in addition to being a neurotoxin, induces cortical inflammation and oxidative stress in our body in general. It increases our pro-inflammatory cytokines, and all the cytokines that you see there in the brain, basically. Those are the cytokines we're talking about COVID. It's inflammatory cytokines that they are the most, I should say, popular, or the ones that have been tested in acute or major diseases. So these are really important pro-inflammatory, and that's what aspartame does. So it is toxic to the body and including the nerves, and because the metabolism leads to wood alcohol. We said before, this is a study that it's been published in Nature, and that shows that having artificial sweeteners, it impairs the glucose metabolism. Now, this is in mice. So mice were fed a drinking water with saccharin, sucralose, or aspartame. And the other group, which were the controls, were fed glucose or sucrose water. So in other words, they were either sugar, natural sugars, or artificial sweeteners. After 11 weeks, their glucose tolerance curves, in other words, how you metabolize glucose, were different into groups. The glucose and sucrose water-fed mice had comparable curves. In other words, they had normal curves. But those who had the artificial sweeteners, they developed glucose intolerance. So it's almost like they were diabetic. So the same thing they did in humans, they gave the upper limit of daily saccharin, the allowable one, and then they noticed that led elevated glycemic response in 4 out of 7 volunteers. There was no response in the other 3 participants. So there was an issue there. The 4 responders had changes in their gut microbiome. That's what they found. So in other words, those 4 and had, who had the other ones, they had something in their microbiome that changed. Then what they did was this, which was very interesting. They transplanted into to mice they were germ-free. In other words, they had no microbiome. They took the microbiome out through antibiotics from the mice, and then they replaced that with the microbiome from humans. So yes, mouse to humans, humans to mouse, excuse me. The mice replicated the glycemic response of the human donors. In other words, the artificial sweeteners had an effect, changed the microbiome in the gut of humans in that case. And then when they took that microbiome from humans to mice, that the mice replicated the glycemic response. So based on prior microbiome environment and maybe diet, artificial sweeteners can induce increase in harmful gut bacteria. So there is an effect on gut bacteria of what do we eat in general, of course, but also the artificial sweeteners. So they are not, just there. They do something. So I'm going to sucralose. I want to say Splenda is what we use, and they are everywhere. That's why I mentioned they are totally ubiquitous. You find them in cereals, in dairy products, in yogurt. We all promote yogurt intake for many reasons, but a lot of yogurt is, is sweetened. It's not the plain old yogurt with nothing in it. So that we have to watch. Sugar for the calories, but also the artificial sweeteners in that. Then we have snack foods, candies, beverages, syrups, nutritional products. We use a lot of those on a daily basis. So how does sucralose intake change how we respond to glucose intake? Again, they took 17 obese adults in one of the studies. They gave them non-regular US users. Half of them took 60 milliliters of sucralose, about 12 ounces diet, and half of them they gave them just plain old water. And then they followed by 75 grams glucose. So sucralose, and then glucose. They measure the glucose, insulin, and other hormones in the blood at different time frames before and after glucose ingestion. So they gave them both after that, the glucose. So the goal of that was to examine if prior sucralose intake changed the glycemic response, the metabolism of glucose, in other words, another hormone like insulin, right? So We wanted to see if having artificial sweeteners prior had changed the glucose metabolism. So what were the results? Those who had the sucralose had higher glucose concentration in their blood, had higher insulin concentration in the blood. They were more insulin resistant. And the conclusion was sucralose is active and it plays a negative role in glucose metabolism. So, having diet with pizza, as we said before, we have a carbohydrate meal with a diet Coke or soda. We all do that. That's not very often. Or pasta may slow down the metabolism of glucose in the meal. That goes back to what we were saying, having sugar and artificial sweeteners together. So it does affect the metabolism of sugar. So you are gaining more weight from that natural, I should say, carbohydrate. So the gut microbiome, we mentioned that here we have fecal matter was culture of saccharine water fed to mice. Increase in bad and decrease in good gut bacteria. Then this transferred the fecal matter from the two groups, saccharine and glucose fed, to germ-free mice. We mentioned that before. The mice that received the saccharine water matter developed glucose intolerance, but not the others that received the glucose water matter. So same thing, is just closing that loop. So if it sounds too good to be true, it is probably is. The medical community, the Academy of Nutrition and Dietetics, recommends them for calorie control and glycemic control. Artificial sweetener consumption may be particularly risky for developing obesity and insulin resistance. It is not clear if there is a safe amount of artificial sweeteners to have in the same diet. And the other thing is that I tangentially mentioned is neuropathy. Those patients or people who have diabetes and that have some neuropathy, the artificial sweeteners are not recommended at all because they are toxic to the nerves and they create more issues. So people have more tingling, people have more sensations. The sensation is heightened of those who have peripheral neuropathy. And a lot of diabetic patients, people have those symptoms. So giving people who have diabetes, giving them artificial sweeteners or recommending diet sodas, it's not a good idea, especially with aspartame. So given the findings so far, I'm leaving this up to you, a food for thought. So would you avoid artificial sweeteners? So I believe that it's not a healthy choice to have them often. So some alternatives, and I'm talking here more neurotoxins in the foods to avoid, not only artificial sweeteners, but I wanted to expand that because we talked about neurotoxins. And so it's good to know, in addition to, sugary or artificial, diet drinks. So we have aspartame is one of the biggest neurotoxins. And like we said before, it exists everywhere. MSG, monosodium glutamate, is in a lot of foods and a lot of processed foods. And it comes in different names. So it is being hidden under, different names. And these are some to watch. There are a lot more, but yeast extract, textured protein, bouillon, we use that for flavoring in our soups and food. Carrageenan, a lot of almond milk and other types of beverages, although they may be considered healthier, or people who actually don't drink milk or dairy products, they might use that. Some of them, not all of them, and I'm not going to talk about brands, but you can, brands who don't have them, they mention that at the front page, front of the bottle. So carrageenan is something that it's neurotoxic. And autolyzed yeast, malt flavoring. So sucralose is another one. Of course, we know aluminum, and we don't use aluminum pots anymore, but they also are in the antacids, in deodorants, in pots and pans. So we need to read the label. And of course, we all know about mercury. And these are the fish that have the highest amount of mercury. I'm going across, and these are the fish that have lower amounts of mercury. And salmon, especially Pacific salmon, I think is the best. So I'm going up here. Stevia is best, and the least processed version is the liquid form that is actually better to have. So the healthier brands of stevia is Sweet Leaf, Stevia in the raw, Purevia. Now Truvia, where most of people use, has natural flavors, and that's the hiding place for MSG. So the other ones are much more, and I'm not promoting any specific one, it's just stevia is a good alternative to other diet beverages, but these brands are more pure, I should say. They don't have other things. So another one is the monk fruit, or they call them the Buddha fruit extract. Luo Huan, like I said before at the beginning, I said keep that in mind, I'll mention it later. This is added sweeteners, but they happen to be healthier, I should say, or less harmful. So I wanted to share these with you, so you have them here because they are, we see them everywhere. And I want to leave you with some alternatives to artificial, sweeteners or products that have added artificial or sweeteners or even sugars. So instead of having yogurt that's already being, flavored, why don't we have plain yogurt and add our own fruits, add our own whole grains in them? I add, flax meal, chia seeds, some nuts. And berries are one of the best fruits with lower amount of sugars and huge antioxidants. Then you can have seltzer water or plain old water and add your fruits in there, and keep a jar in the fridge. You can macerate some of the fruits so you can release the flavor and add some mint. I think these are the best choices. And then you can also make popsicles, especially in the summer. You have some pulp or fruit, mix it up with a little bit of water, and then put it in the freezer with a little stick and make it into popsicles. I think these and many, many other things are very good alternatives to sugary drinks or artificially sweetened beverages and foods. So I'd like to leave you with these thoughts, and I can entertain questions. Let's see, you can always ask the questions later if you come up with any thoughts or ideas or questions later on. You can email, I guess you, Gabrielle.
Yeah, so I'll put the Healthy Libraries Program email in the chat, and if you guys have any questions for us, feel free to email us healthy_libraries_program@stonybrookmedicine.edu. But if there's no questions, thank you everyone for attending, and thank you to Dr. Arcan for presenting this topic.
Thank you.
All right, take care everyone.
Bye.